Well, thank you very much for the invitation to come back. It's 19 years since I ran the Radcliffe Met Station, so but I still take quite a close interest and publish occasional articles. So it's nice to get the chance to review 200 years of weather records and to just think about some of the results that we've got. I thought I'd just start with some very general comments about sort of the value of long-term climate data, because we might sort of think, well, so what? But of course, there are a number of reasons why we might be interested in long-term climate data. Partly the patterns that are there, partly new hypotheses that come along, particularly when you've got 200 years of data. And perhaps the most important one for us, detecting long-term changes, particularly those that we might regard as unwelcome, and looking for subtle signals in noisy records. Long records also give us a chance of placing rare events in context, and I'll just give one example of that later on. And a point that Chris Follen made when we met at the weekend to talk about our various, our two talks, that these days reanalysis relies on long records as well as models. So there are good reasons to conserve these long records and to keep them going. And it may be that the early climatologists were just interested in thinking that climate was constant, and it was a question of really just sort of noting variability. But of course these days we're perhaps particularly interested in directional change, and as I've already said, sometimes rare episodes, which might be a big storm, or it might be a protracted drought, or whatever that might be. Well, what about the Radcliffe itself? Why should we worry about it? Well, of course, it is 200 years at least of long daily records, and there's been a lot of interest over those 2 centuries in the data. Gordon Wallace's little book is a good example, because that is really a history of all the instrumentation, all the observations, and it's good that we have that record collated so that we can check what was being used where and when. Of course, there have been a whole series of observers who've been connected with the station, and over the years people have therefore worried about the quality of the data and checked it and so on. It just happens to be my daughter in the early 90s doing the Sunday observations, which was a good way of earning a bit of pocket money. And this at the bottom is typical of what you find in the ledgers. This is a correction from 1903 by Bellamy, who was obviously going through the ledgers and had found that the original sum was out by 1/100 of an inch for the rainfall, and so there's a record that in fact it should be 1/100 of an inch higher, and there's a nice note in typical red pen just to show the changes. So we've got the records, we've got people who've analysed them, reanalysed them, checked as instruments have been moved around, and so on and so forth. Grateful to Ian Curtis for some of the photographs, and I just wanted to say something about both the site and the situation of the records. The current pen moved on to the north side of the observatory at the start of the Second World War. Before that it was on the south side, and of course over the years there have been instruments on the north wall, there have been instruments on the roof, and so on. So there have been changes, but at least these are documented. Rain gauges have gone up and down in height and diameter, and so on and so forth. I guess since the Second World War there's been a little bit of impact on the site itself, so the sky view factor is a little less than it used to be. Not sure the age of this building, but I think it's post-war, and the site is probably just a little bit more protected than it used to be. And then of course the situation is that we've got an observatory which, when it was built, would have been on the edge of the built-up area, and that particularly from the 1860s, as North Oxford developed, once Dons were allowed to marry, it's become much more urbanised. And Chris will show some results which show the urban heat island effect quite clearly. There was some discussion between Gordon Manley and Gordon Smith about whether Oxford had significant urban heat island effect. I think it would be slightly odd if it didn't. But, you know, the edge of town was here, I guess, in 1770s. I think Observatory Street is 1830s, and then you've got the growth to the north. Well, let's just think a little bit about the records themselves. This is a photocopy of the original ledger. I can't imagine really that I used to have in my filing cabinet the original ledgers. I think they're rather better looked after now than they were then, perhaps, but there they are. So this is one of Thomas Hornsby's sets of records from 1767 when he was, there were earlier Hornsby records from, I think, New College, but or New College Lane anyway, and from the 1760s you've got continuous daily records, but they dwindle as Hornsby got older. I think they stop in 1804 and he died in 1810. But there are some good records, and I'm not sure they've been transcribed, so there's probably a job for me or someone at some stage. The continuous daily record as we now know it actually starts in the middle of 1814. And so 1815 is the first calendar year for which we've got a correct record. So here's middle of April 1814. We can jump on a year and come to May 1815. And so in terms of 200 years ago today, it's kind of interesting to be able to look at, you know, the results that were observed then. 3 observations, 8, 12:30 and 10:30 in the evening, barometric pressure, temperatures without and within, as they're called in the ledger, southwesterly wind, 1/8 of an inch, and cloudy. So those are the actual records that were done 200 years ago today, which is, I think, rather neat. A lot of the records, in terms of being slightly more modern, date from 1827 or 1828. And as I'll say shortly, I've got some doubts about some of the observation practices, even through perhaps to the 1850s. Now, I'm going to say nothing about mean air temperature because Chris is covering that, and so I will keep off the temperature record, although I will say something about some of the sort of related complementary records, because I thought it was important to sort of cover the range of observations that we've got. The ground frost record dates from 1881, I think. So that's it. And you can see that, as you would expect, a general downward trend with some variability. The air frost record dates from 1828, when the 6's thermometers were first being used, max and min. And again, there's a good, clear downward trend in the number of air frosts. And again, you know, quite a bit of interdecadal variability as well, but maybe 15, 20 frosts less, air frosts, than there were nearly 2 centuries ago. I thought it would be interesting just to look at growing day degrees when I was getting ready for this talk. And I suppose very often people use the 5.5 degree scale for sort of grass growing days. There's an alternative index that uses 10 degrees C. That was quite interesting, I thought, because I found some use of that index to work out whether you could grow vines or not. And it seemed to me being able to grow, you know, vines and make wine in Oxford, or Oxfordshire anyway, was quite an interesting thing. So there are the 2 indices of growing season. Much the same pattern, of course, just slightly different accumulated numbers. And if you look for the sort of continuous growing season within that record, as you would expect, the growing season has just widened front and end since 1853, when I was working on that particular version of the record. So starting in early May and ending in sort of mid-October in 1853, but into April by now and to the end of October. So quite a significant widening of the day degree. And if you assume that you need an index value up here of 945 to have a fair chance of growing vines, then you can see that for a good deal of that record, there wasn't much hope, although there might have been if you had the right slope and aspect. But in recent decades, we're up above that, and not surprisingly, people in the Chilterns and so on can run vineyards, etc. So, in terms of applied climatology, if you like, an interesting result. My main interest as a hydrologist is in the rainfall record and related data, so I thought I'd just show you some of the rainfall records and what they show us. And I think one of the interesting things is that over the more than 200 years, because we've got a record recreated back to 1767, which the Craddocks and Gordon Smith worked on. So here's our very long record from 1767, and other than that early sort of decline down to the big drought of the 1780s, then a pretty steady increase in annual rainfall total. And that's driven really by an increase in winter rainfall over the same sort of period. And you can see quite a significant trend there. And of course, if you cut out the first bit of the data, it's even more significant. One of the problems with all of these data, as lots of you will know, is that depending on which period you choose, you can almost get any result you want in terms of correlations and linear trends. What I've tended to go for here are the longest records we've got, and shorter records clearly might give you rather different results. But anyway, I think that's a pretty convincing long-term winter rainfall trend. The summer rainfall doesn't really show the same trend. It shows much more variability, and I think that will tie in with perhaps some of the things that Chris is going to talk about in terms of summer temperatures and so on. So that long-term increase is driven more by winter than summer rainfall. I've not put in spring and autumn just to save a bit of time, but anyway, a lot of variability both year to year and over longer periods. Now, number of rain days. This, I think, is a record about which I've got a bit more doubt, really, in the early years. I've made some sort of correction here for days when they observed snow but didn't measure it in the early years. I think the record is okay from the 1850s, although we're not absolutely sure, according to Gordon Wallace, that daily readings were taken every day until 1881. So some of this early bit of the curve may be too low. So we don't really know whether the 1830s had few rain days or just not so many observations. But of course the later part of the record is clearer, and there are some obviously some quite big changes over that period, which as yet we, I think, don't fully understand. What I was working on yesterday with John Boardman, because we're both interested in soil erosion, was looking at mean rain per rain day, which is of interest if you're interested in patterns of soil erosion. If daily rainfall is in general getting bigger, you might expect a more erosive environment. And that seems to be the case over the last half century. I think this is probably not reliable, so we should probably just look at the later part of the curve. But there's been quite an increase in mean rainfall per rain day, and we were looking at some data from the South Downs, which is even more compelling over a longer period. So these data do have relevance. And of course, if partway through here you suddenly change from grassland to arable, you've got an increasingly erosive rainfall regime and a more susceptible crop type. So one can see how erosion might become more prevalent. And this just sort of sums up the two variables you combine to get the bottom graph. So there's always new things you can look at in these long records, and new things to explain and new things to apply, and so on. This is the record of number of daily totals above 15 millimetres, one index of, I suppose, fairly wet days. I don't know if we had 15 millimetres yesterday in Oxford, probably close to it. I don't think there's much of a trend there. If you, again, ignore these early observations, which were probably accumulated totals, the rest of it is really pretty flat. So no real evidence that there's any long-term trend in heavy falls of rain. There is in many parts of the country, particularly in the uplands, but Oxford is in that sense very definitely a lowland site, and there's not much to be seen here. And here's the annual maximum daily rainfall record for Oxford. Again, I don't think there's any discernible trend there. It just allows us to at least identify the wettest day on record at Oxford, which was July the 10th, 1968, which was the big storm on the Mendips, which had a couple of metres of water flowing down Cheddar Gorge, and parts of Bristol were flooded. And that same storm dumped 87.9 millimetres on Oxford. But as I said, there's no evidence of any long-term trend there, just some variability and obviously one or two extreme events. Now, some time ago, Maria Shagandanova and I worked on a record of long evaporation for Oxford using the record since 1815, and using the Thornthwaite index we calculated potential and actual evaporation, and were therefore able to do a sort of water balance for Oxford. As far as I know, it's the longest record that anybody's tried to re-establish in terms of evaporation, and again, you can do that because the record is there to use. The evaporation figures seem relatively high. Penman used to say 420 millimetres, and Oxford looks more like 500. It may be the evaporation is a bit higher, or it may be that under current temperature conditions that is right. But anyway, the results are what they are. So we can come up with a very simple sort of water balance of, average rainfall about 640, actual evaporation about 500, and therefore a remainder of 146. If you then compare the Oxford runoff record with the Thames record at Teddington Weir, which is the purple line here, you can see that the Oxford calculations underestimate flow in the Thames. And again, I don't know whether that's because we've overestimated evaporation, or whether Oxford is just a bit too dry to represent the whole of the Thames catchment. It could be either of those two. But nevertheless, there's a good correspondence between the curves, and you could very readily add 50 millimetres to the Oxford record and extend the calculation back to 1815 for the river flow. So again, there are useful ways in which the data can be used. Droughts are the other end, of course, of the rainfall record, and depending on which period you take, you get a slightly different sort of period of interest. I'm often interested in 18-month running totals because they tend to pick up where you get two dry summers with a dry winter in between, so 76 comes out low on that scale. The 60-month rainfall running total is interesting because that really shows you very protracted droughts, and it shows you droughts which might be relevant to groundwater sources rather than surface water sources, so relevant to southeast England. I remember in 1992, the Times published a leader to say that we were in the most severe drought ever. So I very quickly penned a letter to the editor to say, no, we weren't. We had some droughts 200 years ago that rather put 1992 into perspective. And in absolute terms, of course, I was right. But actually thinking about it the other day, if you detrend that upward curve, then in fact the 1992 drought was as severe as any other long drought in terms of how far below the sort of local mean it actually was. So in a way the Times editor was right, but probably rather unknowingly, and not quite with the sort of perspective that we would take. But anyway, there were big droughts in the 1780s and the early 1800s, and again, that's interesting to know and have that long-term perspective. So just one or two other brief comments about the observational record, just to show that there are other things other than temperature and rainfall being measured. Hours of bright sunshine, of course, have been measured since the since 1880, I think. There's my daughter again, dealing with the Campbell Stokes, and a rather more recent photo. And you can see an upward trend even in a very noisy record. I think there's a graph on the wall at the back of the same thing. You can use these indices of summer weather to see whether summers have been improving or not. And for about 40 years, Oxford summers were very definitely getting better. They've deteriorated since the turn of the century. And of course, the summer of 2012 was, the worst on record. So we've had bad as well as good in recent times. This is a record of wind speed, just the mean annual wind speed with a running mean going through it. I'm not quite sure what happened in 1995, but I was running the weather station then, so it's either a fault with the observers or 95 was a very calm year. It was a drought year, but I don't know whether it was that calm. I suspect something had gone wrong with the anemometer. But it shows that there are still issues of data quality to be looked at and worried about. This is the incidence of fog, not thick fog, just fog. So it's number 4 on the code and distance of a kilometre. And you can see, as you would expect, the decline with the Clean Air Acts and so on. And what I don't know is whether this is some deterioration in visibility or whether something has changed in terms of observational practice. And again, it would be interesting to know whether there was any change in the 2000s or not. But you still have to be careful with data quality and to worry about whether they're right or not. But it's in a sense, is there some real deterioration in visibility? And if there is, that's something interesting to look into. In terms of rare events, I thought I'd just mention the so-called hurricane from 1987, which was really too far south to really trouble Oxford in any very major way, but nevertheless it came through and the records were recorded, and so we've got records at the top: wind direction, wind speed and gust, the rainfall, the temperature, and then the barometric pressure. So quite an interesting record of what was more or less a bomb depression. It's pretty well 24 millimetres fall in 24 hours. Extraordinary increase in temperature when the cold front came through. I think it was something like 8 degrees in 20 minutes. The increase, most of the rain ahead of the warm front, and of course the biggest gusts and so on in the lee of the cold front. So an interesting event, and one that you can use to put the longer record into some context. I've done some work recently looking at controls with Lamb weather types, so you can only go from 1871 in that particular version because that's when the record begins. But as you would expect, there are strong drivers controlling different parts of the record. The hydrological variables tend to be driven by cyclonic conditions particularly. The thermal variables tend to be more related to particularly to westerlies, and wind speed and sun again correlate with anticyclonic and cyclonic conditions. But there's plenty of evidence of climatic drivers driving the Oxford weather, as you would expect, just as there are with other sites in this part of northwest Europe. Just 2 very final sort of personal bits just to comment. Here's Gordon Manley on his wedding day, and Chris is going to talk about Manley, of course, with the Central England temperature record. Manley married the daughter of the Master of Hatfield College, Durham. Here's my predecessor. You can see, other than the spats, glasses and moustache seem to be de rigueur for Masters of Hatfield. This is a slightly more interesting small world photo. This is my sister's engagement photograph in the gardens of what were then Osler House, which is where we should be at Green Templeton College shortly, May 1963. Over her left shoulder, you can see the weather pen, and who would have thought that her little brother would have been running the Radcliffe in sort of, 25 years after that photo was taken. So it is a small world. Thank you for listening to that review, and I hope you've enjoyed it. Thank you very much.